So far we've been looking at patterns as visuals and turning them into numbers, words, and charts. But what happens when you have a pattern that are just numbers? How do we find the pattern in that example? So first, like before, we look at it in words. What can we say about the pattern? This one in particular, we notice that we can say odd numbers, but we want to get more specific. So we're going to say that it starts at 3 and increases by 2 each time. So it's very specific with one sentence saying where it starts at and what's happening from here afterwards every single time. We can't just say increases by 2. The each time is important because it's saying every term is being increased by 2. So now let's look and put it into a T-chart. Now, when possible, we do want our titles at the top to be specific to our example. So if it has a context like a fence or walls or bricks, we want to use those words in the top of our chart. When we don't have those specific words, well then we can say the term number and term value. So what that is the term number is the order of what it's in. So this is the first, second, third, and fourth term, whereas its value is what's it worth in that spot. So its fourth term has a value of 9. And this is where we're going to go and put those numbers in. So the first term has a value of 3, because we said it starts at 3. The second term increases by 2. The third, again, increases by 2. Fourth is 9. So we can show that increase by 2, or sometimes called the difference value, because the difference between 5 and 3 is 2. 2 and 2. Because these numbers increase by the same amount, we know our pattern is going to be linear. So it increases by the same amount, or if it was to decrease by the same amount, we know it's a linear pattern from these numbers here that repeat. So that's describe in words, make a T-chart, write the next 3 terms. So the 5th, 6th, and 7th term. Well, we know it increases by 2, so that must be 11, 12, 13, 14, 15. And because I made the observation that my numbers were all odd numbers, I know that I haven't made any calculation mistakes because I still have odd numbers here. Find the general nth term. This means that in any given situation, the expression that we come up with, so in other words, find the expression. That's the other way to think about this. Find the expression. So if we replaced n with anything, we could figure it out. So another word for general nth term is expression. How do we go about this now that we don't have our visuals with us? Well, we look at this increasing value. Let's use yellow. If all of these increase by 2, we know we're working with multiples of 2. Well, what's 1 times 2? Let's not use yellow. 1 times 2 is 2. Let's just move this over. What's 2 times 2 is 4. 3 times 2, and you always want to try it with your first 3 terms just to make sure that nothing else is tricking us in the pattern. Now that I've used these multiples of 2, I now look at how close is my new numbers to my actual value. Well, if I increase this by 1, I get 3. If I increase this by 1, I get 5. and if I increase this one by 1, I get 7. So I can say that I have a coefficient, or a multiplier, of 2 times my term number plus my constant of 1. Every time I added 1, and every time I multiplied by 2. So I can multiply, remember that dot means multiplication, 2 by any term number, add the 1, it'll get me the value in this column. I can check my answer by picking any one of these to check. I'll pick the 5. So term number 5, five times 2 is 10, plus the 1, plus 1, gives me 11. And that's what I said when I did my normal arithmetic in my chart, is that it was going to equal 11. So we've done finding the expression, or the general nth term, because we said algebra is generalized arithmetic. Find the value of the 25th term. So now when n equals 25, what's the value going to be? Well, we do the same thing. We do 2 times 25 plus 1. 2 times 25 is 50, plus the one that we haven't used yet, because BEDMAS tells me to do my multiplication first, is 51. The only thing I'm missing here is I should have had my equation, or my expression to start it off, 2n plus 1, so it shows me what I'm substituting in. And then I can answer the question by saying there are, let's see, the term value is 51 for the 25th term, or something of that nature. So now we've completed this. Graph the first 4 terms. Does your calculations for the 25th term look about right? So you're going to graph this piece as your follow-up homework. Right now, when you're done this video, you're only going to plot the first 4 dots. So you're going to plot the ordered pair of 1, 3. You're going to plot the ordered pair of 2, 5. And you're going to plot 3, 7. And then 4, 9. Connect those with a ruler and extend your ruler and your line past 4, 9. And let's see if it looks about right if we were to look at the term number 25, and if we went all the way up our line, would it get us to 51? That's where we'll check in class. Coming into class tomorrow, you should have these 4 points plotted on your graph and connect them with a straight line past the 4th dot.